Alrighty, welcome back, boys and girls. It's your main math man, Mr. Jen, coming to you live from Mayfield. In this video, we're picking up where we left off, working on that study guide on page 9 now, and you're trying to graph a linear function when given an equation in that slope-intercept form, which is that y equals mx plus b. So a couple things to know with this. Again, there's always more than one way to graph or solve a equation, and being able to graph that function. Also, you want to make sure that you are graphing that line. It should be a straight linear function, meaning a straight line. Make sure you can identify your slope m and your y-intercept. So again, I usually highlight in orange the y-intercept, which is where it hits the y-axis, and then we say our slope is attached to m. So again, that's always the change in y over the change in x. So if we have for this first one, it says which graph best represents the following equation. So it has y equals 1/2 x minus 2. And so right away I can identify the y-intercept. I can say, all right, it hits the point -2. And if you look on your graphs, again, being able to identify the y-intercept is probably one of the easiest things to help you out. If you look, you notice, hey, I know these first two I cannot choose because they hit at +2. So I can eliminate those right away. And then also too, I can see, all right, what if I highlight my slope, what kind of slope do I have? Well, I have a positive slope. I can say I have a positive slope. Again, that's m, which is attached to the variable x. And if you're looking at positive slope, we would know that our only option would be d. You can also check to make sure, because we say our change in y is +1. So if I go up one step, I have to go to the right 2 steps to get my next ordered pair, which I do, so we know we're right. And the second one, it says which equation best describes the graph. And so again, same idea. We can say we want to find our y-intercept first. So we have our y-intercept, and that's going to be the point. So we can say this b is going to be -3. And then we want to find our slope. So we can say again, from that ordered pair, I can go up 2. I can go up 2. So I have +2, and I go to the right 1. So our change in y is going to be 2, and our change in x is going to be +1. So that means when we write our slope m, it's going to be 2/1, which is just 2. So when I'm looking for this, again, I need to find where m is 2 and our y-intercept is -3. On the back, it says graph the equation -1/3 times x. And if you ever see this, you can see, hey, what is our y-intercept going to be? Well, if you're unsure, plug in where it has x equals 0. It would go through the point 0, 0. So again, the reason why they don't write +0 is that would be redundant. And so your y-intercept would just be 0 itself. So that means I can go from that ordered pair. Let me actually plot that like this. I can say from the order pair 0, 0, I can go through that point. Let me try plotting that a little bit simpler. Again, a couple different ways you can do this, but I'll show you at least 2 of them. So then I have a negative slope, so that means I have to go down. So I'm going to go down 3. So if our slope says minus, let's say, we say 1 down, 1 down, and then we could say 3 right, because our change in y is -1, and our change in x is +3. So I have to go down 1 and to the right 3 to graph my point. And the way we can check it is again, using that table like before. So let's see. It said that I had the order pair 3. Let's say we have 3 and then -1. Well, is that satisfying our slope here? So we went down 1 in the y, and we went +3 in the x. You can also, let me draw this line real quick. Hopefully it's not too bad. So we went 1, 3, up 1, 3 left, up 1. So I can go through these points like so. And then I can also check using that Desmos calculator for ourselves. We said that if we plug in our function, we have y equals -1/3 times, let me try that again, 1/3 times x. And if we let x be 0, our y value is also 0, so we're good with that. And it says if our x value is 3, our output is going to be -1. So again, make sure you're seeing these order pairs. Again, it said x is 3 and y is -1, so we know we are good. For number 4, it says plot 3 points that lie on the line 2x minus 5. And so again, this is just like our homework that we've been doing. So usually I use and make those tables from before. However, again, you can keep it simple for yourself. You want to say, hey, right there's my y-intercept. So I have to plot the point 0. I have to plot the point. Let me go over a little bit. And let me try this one. There we go. So let me do it like this. I want to say I need to plot the point 0, -5, because that is our y-intercept. Again, it's always where x equals 0. So we have the point 0, -5. And it says our slope is going to be positive. So we're going to be going up 2 steps into the right 1. So I go up 2 steps and then to the right 1. So I have +2 for the change in y. And my change in x is +1. So I go to the right 1. So I have +1. Let me plot that point first. So again, you can use that staircase, or if you want to use that ladder, again, we said we have to go +2 in the y and +1 in the x. Say +1 in the x. And so that means, again, we get the order pair -3, and for x we would have 1, which is that order pair there. Again, graph the line of our function. Let me actually use the right color this time. So let's go through these points. So we said 3, something like this. Again, you want to make sure you're going through those 2 order pairs. That way you can see that it hits other order pairs as well. So I'm claiming this. I have to plot another point too. So I need to say, well, what is another order pair that goes on this line? Well, we can still use that same pattern. We can say, again, I go +2, I go +2. Again, any of these order pairs would work. However, make sure if you're given values in a table form or order pair, they might not always have the same space, but they would be on this line. So let's say for our x, again, it's +1, +1, and +1. I'll give a couple other options. And so that means we have the order pair 2, -1, which is, we have 2, -1, which is that point right there, so we're good. And we have the order pair 3, +1, which is that point right there. Again, notice how it is directly in that corner for ourselves. Again, another way to check for yourselves or to see how to get these points. Let me move this, slow it down here maybe. Perfect. All right, so we said our equation is y equals 2x minus 5. plug in where x equals 0, get our y value of -5. So this is one set of ordered pairs. Plug in 1, our y value is -3, and if you plug in 2, our y value is -1. So again, we know we are good with those. For the other ones, it looks like this. You want to make sure you can match the graph that represents the function. So I want to be able to identify what type of slope and y-intercept, that way it is easier to do. Again, I could check using those ordered pairs, but I want to make sure it is very simple for ourselves. So for the first one, our slope is -2. So we have to find a negative slope, which the only one is b. So our, let me actually write it here. Again, our only choice for negative slope is b. So in the second one, our slope is 1 and our y-intercept is 0. So it passes through the point 0, 0. Well, of the only options left, since we said we chose b already, our only other option that has a positive slope and passes through point 0, 0 is the letter D. So you'd say for this one, our choice is D. Moving on to number 7, it has our slope is 3 and our y-intercept is +1. So again, make sure you can find those y-intercept for yourself. And if you notice between these two, they are both a y-intercept of 1, which makes sense because that is what we have. However, the number 7 is going to have a steeper slope, so it should be a steeper incline. And you can notice that because our value of 3 is going to be greater of a slope than 1/3. So we could say for this one, this is going to be A, which leaves C for number 8. Again, a way to prove that C is 8, you could say for each one step up we go, so for each step up we go, I have to go 3 to the right, so I go 1, 2, 3, and I hit another ordered pair. Again, that's from our slope, which is change in y or change in x. And lastly, for this one, it says which equation best describes that graph. So again, given a graph, highlight that y-axis, identify your y-intercept. So we'd say b for this is going to be -2. Our slope is negative, so we know we have m is going to be a negative value. And let's see if we go down to, again, I use that ordered pair, and I go down 2 and to the right 1. So our slope should be -2. So let's make sure here. So we have -2 and we have +1. Again, change in y over change in x. That would give us a slope of -2. So that means for each 2 steps down, we move 2 steps to the right. And so we need to find our equation, whereas a slope of -2, which would be this choice, and a y-intercept of -2 as well. So for that last one, we would know to pick that third, or that last option. Again, if you can use the Desmos calculator check, you'd say, let me move this down a little bit, you'd say, well, when y equals -2x minus 2, not 23, I want -2x minus 2, I can say, what happens when x equals -3? Well, according to this graph, it should be 4. So if I plug in x equals -3, my output is 4, so we know we're good. However, I want to make sure I have 2 points, so let's do -2. And yes, it does check out, so we know we are good.